Okay, now I'm going to do another example of how you can swap things in the top there using our algorithm. And what we're going to do is use our algorithm in the same way that we do a moves that one move, then another move, undo the first move, and then undo the second move in the commutator fashion. So we do an R, a move, R prime, and then we undo the other move. So there's in between there's a U move. So we do R, U, R prime, U prime. We're going to do our whole algorithm, and then we'll do it again from the left, and then do the inverse on the right hand side, inverse on the left hand side, and it looks like this. We're going to go which is an interesting thing to do because it doesn't look like it's done anything. However, when you look on the sides, you see that we've managed to exchange the edges. So this is what's called a U permutation. What it's done is does it in a clockwise fashion. So this it does it in an anti-clockwise fashion. Sorry. So if you start with the right, it's an anti-clockwise fashion. So it moves this piece to here, this piece to here, and this piece back to here. So if we take this is the same permutation. So we're ready to flip all the edges and move on to the last piece where we solve all the corners, and we want to sort this out. Now, I started with the right hand side where there's an opposite, as you see. So in this case, if we start with the left hand side where there isn't an opposite, we start the opposite side to the opposite colours, as it were, and we do our algorithm, and we do our algorithm, and then we undo the first one, and we undo the first one. It's quite complicated to follow, but what it's done is it's swapped those edges, and we're in a position to do the last corners. So that's a useful way if you're able to spot this situation from any angle where you've got a cycle of 3. You can use our algorithm which is a commutator of R and U moves, in a commutator of itself, and you can solve the edges. Slightly more advanced, but might be useful.